Hey friends, welcome to the math review for chapter 2. I'm going to skip the intro. I'll let you guys read that on your own. It's basically mostly the same as the was last time. Some suggestions for how to review. Of course, you can find other ways to review as well. And then I'm just going to jump into the questions though. Here's chapter 2.1. So the first section that we'll be covering. And there will be at least one question from each section on the exam. Okay, 2.1. Oh yeah, I'm gonna make it. It's a little bit. It's gonna be a little shorter than the last exam in terms of numbers of questions. I'm not sure I'm not sure with certainty that it's gonna be shorter time wise because I think some of the graphic ones do take time. But I'm thinking to make it a little shorter. Um, There's two less sections, so that's kind of natural too that it would turn out that way, and a lot of overlap with the sections. Okay, here we go. Anyways, sorry, I keep getting sidetracked. Let's do 2.1. Number one, 2.1 is about quadratic functions, right? So these are all quadratics. Number one, write the equation in vertex form and then determine the vertex. Okay, what you see in all three of these questions, you're gonna have to complete the square. And completing the square is kind of one of those skills that we want to just make sure that we carry through with us going to the next math class that you might take. So, in other words, guarantee you're going to see completing the square on this next exam and probably in your future. Okay, let's do it. So when I complete the square, what I like to do is to just kind of separate the part that I'm trying to complete the square with, like this, and then leave everything else outside. This plus 2 gets pushed to the outside of the parentheses. Within here, I'm going to complete the square. So what do I need to complete the square here? I want half of that middle guy, right? Half of that middle guy squared, which is 1 squared. So I'm going to add that. But if I added it there, well, I want to compensate here by subtracting it. Right? Yeah, when we did this with the circle equation, remember that? And at that time, we had an equation, so we could actually just like do the same thing on both sides, right? But if you do it on the same side of the equation, if I was to plus 1 here, it would translate to subtracting 1 on the same side of the equation, right? So that's what I'm doing here. I'm just adding 1 and subtracting 1, and you're allowed to add in 1 and subtract 1 because you're not changing anything, right? If I add 1, subtract 1, it's like adding 0. It's not actually changing overall. It's just kind of doing it in a little clever way. All right, so this part is the part that's now a complete square. So that turns into x minus 1 squared. If you don't believe it, FOIL it, check it out. And then here I've got 2 minus 1, which is just plus 1, right? So I've got f of x equal to x minus 1 squared plus 1. And this is in vertex form now. So what is the vertex? It's 1, comma 1. Yeah. How did I get 1, 1? Well, okay, let me just remind you here. If you've got a function of this form, x minus 1, oh, sorry. Oh, the general form. X minus h squared plus k. Then your vertex is at hk. Remember, this is the minus here. So if it's minus, this is h is a positive. And if it's plus, and this is positive, I just keep erasing and rewriting it. So this is a minus 1. That means the x coordinate is a positive 1. This is a positive 1, so the y coordinate is a positive 1 as well. Okay. So that's question number 1 complete. Moving on now to question 2 then. Question 2. Determine the vertex, max min, axis of symmetry, domain range, intervals of increasing, decreasing, x-intercepts, y-intercepts, and sketch. Okay. So first thing, determine the vertex form to determine the vertex. And actually before that even, I'm just going to rearrange this a little bit so that my x squared term is in the front, okay? Okay, so to do the vertex form this time, I don't like to work with these negatives when I'm changing to vertex form completing a square. So I do a little trick personally. I just factor out that negative in the front. And then this is going to be x squared plus 2x. And then I give myself some space here. And the constant guy, I'm going to leave outside over here. I'm not going to touch the outside guy. I'm just going to leave it as a plus 6. Okay, so this plus 6 is not related to this negative that was factored out. It's just move this thing over to the side so I don't have to deal with it as I'm completing the square. And then all the part that I am working on completing the square with, that's going to stay in this parentheses here with the factor out -1. Yeah. And this factoring out, by the way, this thing I just did just now, that works if this was like some other number, like squiggle. Like if this is 8, then I just factor out that 8, and then I work with completing the square inside. And then, yeah. Then the other thing to watch out for, though, is when you figure out what you should be adding on and subtracting here and here, then remember to cycle this guy through whatever is factored out over there. Okay, so let's do it. How do I complete this square? X squared plus 2x. What's the thing I should be adding? It's the square of half of 2. Half of 2 is 1. Squared is 1. So I should be adding 1, right? But if I add 1, how does this affect things cycle through this negative that was factored out? Well, if I add 1 times -1 is actually a -1, right? So in effect, right now, I'm subtracting 1 from this top original equation. So if I'm subtracting 1, then to compensate, I actually have to add 1 on the outside. You see that? So you cycle this guy through this thing, and it turns out to be equivalent to subtracting 1. But I want to compensate. I don't want to subtract 1. I want to keep things level, keep things even. So to compensate, I do the opposite. I add 1. Okay. If that doesn't make sense to you, then just rewatch this portion, rewind, do it slow, do it by yourself until it does make sense to you. Let it sink in so that you'll be able to reproduce that same action later. Okay, so now everything is looking great. Here, I'm going to rewrite this as a complete square. That's x plus 1 squared, right? And you notice you have this negative that carries through right there. Right? I got this completing the square part happened inside that parentheses. This negative thing should not be affected by it. It's still going to be coming down with that. And here I have plus 6 plus 1. That's plus 7. Okay, so boom, there is my vertex form. And what is my vertex then? Vertex here, h, it's x minus -1, right? So h is equal to -1, and k is equal to positive 7. Okay, as I'm doing this, guys, I also just remember that there's an alternative way to do this, right? Which is to just skip what I did and plug in the formula for finding hk. So I remember, yeah, we did that when we were doing section 2.1. And to do that, remember because honestly I forget the formula. So here's what I do remember though, is the quadratic formula. Right, you remember all this, right? And then if you just forget about that square root portion, right? You get b over 2a, negative b over 2a, and that tells you your h coordinate, and you can plug that in to get your k coordinate. Here, you know what? There, I'll show you in practice, okay? So we actually went through the process of finding the vertex. A vertex is -1, 7, right? So here's the alternative method to do that. We take x equal to negative b over 2a, and then I'm going to want f of negative b over 2a. Here, negative b over 2a, we're starting from this original starting position, right? So, as I'm doing this, guys, what I want you to take from this too is that even like I forgot the formula off the top of my head, but I could just recall it by just kind of reasoning through it. And even if I didn't have the formula, I'm able to just complete the square to solve the thing regardless. So kind of just, just a little takeaway for just how you approach math in general. We want to kind of think through things with like not just what you're doing routinely, but also where it come from. What are we really doing it for? So let me show you how this works though. So negative b would be b is -2, right? Negative b would be positive 2, and 2a, that would be 2 times -1. 2 times -1. So that would be negative 2 over 2 is 1, and that's -1. So look, that matches h, right? And then what's f of -1? Okay, so plug it -1 into there. I've got sort of low on space here. I did this the wrong way. Let me do this below. What's f of -1? That would be negative of -1 squared minus 2 -1 plus 6, which is -1 plus 2 plus 6, which is 7. So okay, that matches the k. Yeah, so sweet. Okay, so all I did is just confirm that the alternative method gives me the same vertex. All right, once you have the vertex and just one more small piece of information, which is that this leading coefficient right here is a negative value. This negative x squared part. That tells me I'm opening down, so I'm gonna go straight. I'm gonna skip to the graphing part. A quadratic. I have a vertex of negative 1, 7. And I'm opening downwards, right? Because I got a negative leading coefficient. So with that in mind, the other parts of this question are easy. Got the vertex. The max, there is a max, is at negative 1, 7, right? The vertex, yeah. The maximum value is 7 occurring at negative 1. So that's that. Axis of symmetry, that's just the line that splits the parabola in two. So axis of symmetry is x equal to negative 1, which is just negative 1 value, right? Domain and range. Domain is everything. And the range is from negative infinity up until that 7, including the 7. So hard bracket there. That's that. Intervals are increasing, decreasing, increasing until you get to the middle. So from negative infinity up until negative 1. And then decreasing after that from negative 1 onwards. Yeah, that's that. And then the xy intercepts. Okay, xy intercepts. Hold on a second. Let me make some space for myself. Okay, so I'm gonna erase all this work here. For the xy intercepts, the x-intercept is easy. I'm sorry, no, the y-intercept is easy. You just plug in 0 for x, right? And then the x-intercepts, that's where you just use the quadratic equation. Let's do y-intercepts first. So that's when x equal to 0, right? So when x equal to 0, then you get 6 minus 2 times 0 minus 0 squared, which is just 6. So the y-intercept is 0, 6. That means when I drew my graph here, it was pretty inaccurate. It should actually been right like that. Something like that. Okay. What about the x-intercept? I'm going to just plug it into the quadratic equation here. I've got, oh, shucks, I erased a little too much here. Let me write it here. This is negative x squared minus 2x plus 6, yeah? So I'm just going to plug into the quadratic equation. That's negative b, which is 2, plus or minus the square root of b squared, which is 4, minus 4a, which is negative 1, c, which is 6, all over 2a, which is 2 times negative 1. Which is 2 plus or minus square root of 4 plus 4 times 6 is 24. So that's going to be 28, right? And all over negative 2. Okay, that's kind of nice. It's going to be 2 plus or minus 20 is 4 times 7. So I can square root of 4 to get 2 root 7 over negative 2, which is everything divisible by 2. Right? So I get negative 1. 2 divided by negative 2 is negative 1. 2 divided by negative 2 is also negative 1. So plus or minus negative square root of 7. But since you're plusing or minusing a negative 7, it's the same as just saying plus or minus a regular old square root of 7. So I got negative 1 plus root 7, negative 1 minus root 7. Okay, so those are the zeros for to find the x-intercept. So what are the x-intercepts though? That would be negative 1 minus root 7, comma 0, and then negative 1 plus root 7, comma 0. What are those values though? Let me just punch those into calculator to get an approximation so we can get an estimate for where to graph those. So negative 1 minus the square root of 7 is negative 3.6. This is about negative 3.65. And then negative 1 plus the square root of 7 is about 1.65. So that kind of tells you where these would have been. Yeah, negative 3.65 and positive 1.65. Okay, that's the sketch. We did the sketch already though, and we've answered all those questions. That was number 2. Okay. Okay, number 3, one more. Yeah. So, like looking at these things, they're all pretty similar, like 1 and 2. Probably what would make sense to me, actually I could see a couple of ways of doing this. I'm just thinking through out loud how I would write your test questions. Maybe like one quick question like number 1 might be an easy one to like kind of a giveaway question to you guys. And then I might add another one like either 2 or 3. Or maybe some hybrid of both of them. Because 3 is another case where I'm kind of going through this. I'm kind of doing 2 again and just tacking on that inequality part too. I'll show you what I mean. Let's do it. So I've got x squared plus x minus 8. Solving this inequality using graphical method. What's really important here though, so, okay. I have a quadratic, right? And it's an x squared term positive, which means it's opening up, parabola opening up. Maybe there, might be there, might be there, might be there. It's a parabola that's opening up, right? And I want to know when it's less than 0. So the important part for me, I don't actually care about the vertex. So now that I'm talking through this, it does make sense to maybe do some of both of these. So to include like a portion where you have to graph the thing, explain the vertex, axis symmetry, blah, blah, blah. And then maybe tack on that inequality portion to it. Okay, so what I really care about though is I just care about where do I cross, right? If it does cross. And then from there I can determine, okay, where is it below 0? Where is it above 0? In this case, I care about the below 0 part. So in other words, the most important thing for me is just the x-intercepts. And so I'm going to just solve it using the quadratic equation here. That's -1 plus or minus the square root of b squared, which is 1, minus 4a, which is 1, c, which is -8, all over 2a, which is 2 times 1. Let's change to green. So it's -1 plus or minus the square root of 1 minus 4 times -8. 4 times 8 is 32. And this is 1 plus that. So it's 1 plus 32, which is 33 over 2. Okay, which is not a very nice number. Just double check I didn't make a mistake here. That's for AC. Yeah, that looks right. Okay. So, okay, this is going to be -1 minus square root of 33 over 2, or -1 plus square root of 33 over 2. Right? Those are my zeros. And those are kind of ugly numbers. So I'm just going to approximate them. -1 minus the square root 33 and divide by 2. This is approximately -3.37. Or these are squiggly equals, yeah, because it's approximately. Okay, or -1 plus the square root of 33 divided by 2 is approximately 2.37. Okay, so plot that. -1, 2, 3, 4. This is somewhere in between right there. And then positive 2.27. So 1, 2, 3, somewhere over there. It's a parabola opening upwards. So it goes something like this. And importantly here, it's less than or equal to 0 in this region in between. Right? So with that information, I'm already ready to answer the question. The answer to my question. Where is where is x squared plus x minus 8 less than or equal to 0? Well, less than or equal to 0 means it can be 0. So negative 3.37 to positive 2.37. Or if you want a more exact answer, in this question, I think we didn't specify whether to round or not. So, you know, if I'm grading you, I would accept either version as correct. Yeah. Okay, so there you go, guys. That's it.